Hi, everybody. Welcome back. Now we're going to talk about log functions again, but with a different type of base. So we did the log base 10, base 2, base whatever, regular whole integer numbers. But now remember the E number that we learned before, 2.71, etc. So whenever the base of a log is E, it has a special name. It's called a natural log. And so that's what I'm going to go over now. And so the parent function is going to be y equals e to the x. And if you have a log with a base e, we call it a natural log. So ln. So ln x and e to the x are inverses. So this is exactly the same as what we just did, but instead of a number for the base, like a 2 or a 3 or whatever, it's going to be e. So hopefully you guys remember that. So let's just make a little table here. So negative 1 is 0.4, and then e to the 0 is 1, and e to the 1 is just 2.7. You can just round it. Whoops, there goes my paper. And so for exponentials, remember we have a horizontal asymptote. This has a horizontal asymptote of y equals 0. Let's graph it. So negative 1.4, 0, 1, and 1, 2.7. And the domain here is all reals, so negative infinity to infinity. The range is from the asymptote up, not inclusive because it's a dashed line. So there's that. Now for the natural log, which is the inverse, you're just going to take those points and flip them. It's exactly the same thing. So 0.4, 1, 2.7, negative 1, 0, and 1. And remember, instead of a horizontal asymptote, it has a vertical. So this has a vertical asymptote of x equals 0. So 0.4, negative 1, 1, 0, and 2.71. And remember, just like on the other side of this paper, when we did regular logs, it's just a reflection about the line y equals x. So the domain and range are flipped. This is 0 to infinity, and the range is negative infinity to infinity. Wow, my infinity symbols are getting a little lazy there. So that's the basic idea. Let me fill out this other part here for you. So if you have the exponential, you do the inverse, swap those. So then when you rewrite it in log form, log base e, y equals x. And anytime you have log base e, like I said earlier, it's just ln. Okay, and we already did the table. So now let's do some of the graphing. So just like before, we want to do our parent exponential, our parent log, and then the shifted log with the translations. Okay, so I'm going to do my parent exponential. I'm just going to write it all out while I'm doing these. So it's exactly the same for all three of these. And because it's ln, they're always e to the x. Okay. Otherwise, you look and see what the base is for the log, and then that's your parent function. So we already wrote these out up top. So I'm going to write them again. I know this feels very repetitive, but the more you do this, faster you'll get at it. You'll just feel so much more comfortable and confident with the math. It's awesome. You guys are going to do great on this. Okay, so after the exponential, then we want the parent log. This is where we switch. Okay? And remember, the log this time is not just the regular log like the log, it's the natural log, which is the ln, because it has a base e. We never write log base e, it's just weird. There's a special name for it, it's natural log. That's what we always do. We don't write log base e, that's just crazy talk. Okay, so I'm going to flip the table. So 0.412.7, negative 101. Same thing here. 0.412.7, negative 101. For a lot of these problems, the very beginning of what you're doing is the same for every single one. Okay, so now we're going to do the final with the translation. Okay, so let's look at these. This one doesn't have any, so has a vertical asymptote of x equals 0. And then we have 0.4, negative 1, 1, 0, and 1, 2.7, 1. So there's our parent function, 0 to infinity, and negative infinity to infinity. All right, parent function. Good job. This one has a +3 inside the parentheses. So that means it goes to the left 3. So I have to minus 3 from the x coordinates. To minus 3 from the x coordinates. So 0.4 minus 3 is negative 2 point something. Like I said, it's usually late when I'm doing these. 2.6. All right. 1 minus 3 is a negative 2. And then 2.7 minus 3 is negative 0.3. All right. And then these guys stay exactly the same. Now, because it goes to the left 3, remember, anytime a log function moves left or right, it changes the asymptote. Just like with exponentials, if you move up or down, it changes the asymptote because it's horizontal. Well, this one's vertical. So I'm going to go left 3. 1, 2, 3. Try to make sure I count correctly this time. Been doing better. So now I'm going to graph these. So a negative 2.6, negative 1, negative 2, 0, negative 0.31. And then if you want, you can see where it crosses, where it crosses the y-axis. The domain here is negative 3 to infinity, and the range is negative infinity to infinity. And then same thing here. Inside there, it's a minus 2, which means it goes to the right 2. So I'm going to do +2, +2, +2. And then out here, it's a -1, which means it goes down 1. So -1, -1, -1. So for my final, 0.4 plus 2 is 2.4. 1 plus 2 is 3. And then this one is 4.7. -1 minus 1 is a -2. A -1. This is a 0. It goes to the right 2. So do your asymptote first. Highly recommend you do that. And then 2.4, -2, 3, -1, and 4.70. And the domain is 2 to infinity, and the range is negative infinity to infinity. All right, hopefully that made sense. Thank you.